Right, in this question we're going to calculate the refractive index of a particular substance. So what we're given in the question is an angle of incidence and an angle of refraction, and then we have to calculate n, and we're going to use the relationship sine I over sine r is equal to n, and n here is the refractive index. So that's the refractive index, and this overall law is called Snell's law. This relationship. It's also the second law of refraction. The first law is that the incident ray, the normal, and the refracted ray are all in the same plane. So this is the second law that says that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a particular substance. So we have a particular substance and we've got a ray of light going into it, and we're told that the angle of incidence is 45 degrees. So let's draw a diagram. Here's our substance, and we've got a ray incident like this, an incident ray like this, right? And we've got it refracting like this, so it bends at this point. Okay, so if we want to look at what these angles are, we have to put in the normal, which is something that we didn't, that doesn't exactly exist in the question. You have to kind of put it in there so that you can see what it looks like. And in here, we've got I. This is the angle I. Remember that the angle is always from the normal to the incident ray. That's the angle of incidence. And if you look in here, we've got or, from the normal to the refracted ray. So that's going to be or. Okay, we're told in this question that I is equal to 45 degrees. And we're told that or, the refracted ray, makes an angle of 33 degrees with the normal. Okay, so how do we calculate the refractive index then? Well, we have to do the refractive index using this relationship. So n is equal to sine I over sine r. So we're going to use our calculator for this, but we have to fill in all our values first. So n is equal to, well, it's the sine of I is 45 degrees, and then r is 33 degrees. So now we have to put this into a calculator. So let's work out we'll do this in steps so that we can see easier what's happening. I want the sine of 45 degrees, so I have to hit sine 45 and then I close the bracket and hit answer. And I find that that is 0.7071, we'll say, over, we have to do the sine of 33 degrees, so we do sine of 33 and close the bracket, and we get 0.5446. Okay, so normally you would just do this all in the calculator. You would type in sine of 45, close the bracket, divided by sine of 33, close the bracket, and that'll just give you out your answer. But I'm doing this in steps, so there will be a little bit of inaccuracy here because I'm rounding now. But let's look at what we get. Well, now I have to divide 0.7071 by 0.5446. So 0.7071 divided by 0.5446. And I get n equals 1.298, or we could say n is roughly equal to 1.3. Now the units here that you use for refractive index, there are no units, because if we look at the formula, this is sine of I. Now sine has no units. If you get the sine of an angle, you don't get any units, because it's just a ratio. If you get the sine of or, again, that has no units. So it's something without units divided by something without units, and so you end up with no units in the answer. So your overall answer here is n is equal to 1.3. That's how you calculate the refractive index.